Okay, so let's take a look and see how much you remember from last week. This first one up here, we go to graph it. Of course, looking at all these, we can see that all three of them are lines. We go to graph that first one. Where would we start? Now, if you recall, there's two pieces of information. The number that multiplies x is the slope. That tells us how steep the line is going across the graph. The other number, the numbers by itself, is the y-intercept, and that's where we start. That tells us from the center, from the origin, how far do we go up or down to start the graph. So this one is -3. So from the center, we go down 3, and that is where this line starts. A slope of 2, of course, has to be changed into a fraction. We make it 2 over 1. So now from that point, we rise 2 and run 1. There's our line. The second equation here, we see that the y is not by itself. In this one, y was by itself on the left side of the equation, which is what we call graphing form. If it's in that form, we can pick out that slope and y-intercept like we've been doing. This one is not in that form, so it is not ready to graph. We have to get the y by itself first. So to do that, we have to solve it just like we would solving for x in a single variable equation. So we're going to add 1. Well, when we add or subtract, we only have to do it to one piece on each side of the equation. So we add 1 to that -1, it makes it go away. That leaves us with 2y. On the other side, the only place we can add 1 is to the 5. So the 3x is not affected. 5 plus 1 is 6. And then we divide by 2 to get rid of the 2. So what we have is the y is by itself there. I'm going to write it over here. The y is by itself. The 2 is gone. It's canceled out. 3x divided by 2. Remember, we said we use this relationship between division and fractions. 3 divided by 2 comes out of as just 3 over 2 x. Plus 6 divided by 2 is 3. So that's telling us that on our graph, we are going to start at +3. From that point, then our slope of 3 over 2, we're going to go up 3 over 2. Any questions so far? Okay, so then as we move to the next one, the last one, again, the y is not by itself, so we have to get it by itself. Now, it's a little bit more confusing because x is over on the same side as the y, but that really doesn't change anything. We're going to do the same steps, only we're going to take, instead of just subtracting a number, we're going to subtract the 5x. So cancel out the 5x. It's gone. We have 2y here. On the other side, there really isn't anything to subtract the 5x from. So 4 minus 5x is just 4 minus 5x. Then we'll divide by the 2, which leaves the y by itself. Dividing by 2 over here. 4 divided by 2 is 2. Now this is a -5x divided by 2. Gives us a -5 over 2 times x. So that one is telling us we have to start at +2, which is right there. And the -5 over 2 that's multiplying the x tells us from that point we have to go down 5 and over 2. There's our second point on our line. No, remember when there's a negative on the slope, it goes with the rise. The run is always positive. It's always right to left. Or sorry, left to right, I should say. Yeah, it's a -5 over 2 is the way you interpret that. Now we did work with some non-linear equations. We had things like this. y equals, I will go 2x squared minus 5. To graph that, of course, if we work with these long enough, you would know that that x squared means it's going to form a parabola or a U-shaped. But the only way we've learned how to graph them, and as far as we're going to go in this course, is to use a table where I'm going to pick values of x and I'm going to plug them in to figure out what y has to be. So I might pick -3, -1, 0, 1, and 3. So to figure out what y has to be, I'm going to figure them out off to the side over here. I'm going to put in the -3 where the x is. So it's 2 times -3 squared minus 5. Well, -3 squared is a positive 9. Remember, anything squared is a positive. On your calculators, you actually do have to put parentheses around a negative before you hit squared, or it's going to give you a negative answer, which would be incorrect. So -3 squared is a positive 9. 2 times 9 is 18. Minus 5 is 13. So that gives us the point -3, 13. Well, -3 is this way. Now, also keep straight that when we're dealing with a coordinate, a point like this, in the ordered pair, the first number is the horizontal, the side to side. The second number is the y, the up and down, vertical. When we did slopes, it was just the opposite. The top number was the rise and the bottom number was the run. So make sure you keep those straight. So we go over -3, up 13. Going to be off the top of our graph, somewhere in here. If x is -1, y is going to be 2 times -1 squared minus 5. Well, -1 squared is 1. 2 times 1 is 2. Minus 5 is -3. So that gives us the ordered pair. If x is -1, y is -3. So -1, -3 is right there. If x is 0, y is 2 times 0 squared minus 5. Well, 2 times 0 is 0. Well, 0 squared is 0. 2 times 0 is 0. Minus 5 gives us -5. So that gives us the point when x is 0, y is -5. So 0, -5, right there. We'll try x is 1. Y is 2 times 1 squared minus 5. 1 squared is 1. Times 2 is 2. Minus 5 is -3. So when x is 1, y is -3. So 1, -3. If x is 3, y is 2 times 3 squared minus 5. 3 squared is 9. 2 times 9 is 18. Minus 5 is 13. So that's at 3, 13 again. Way up here again. So that gives us a curve that looks something like that. That's our parabola. There will be questions on those on the test, just so you know. Make sure you are able to plot those points and graph them out. Okay, so next, we want to move into now the next step, which is looking at variation. Variation talks about the relationship between two amounts, two variables. And there are two main ways that two variables can be related to each other. They can be directly related, or they can be inversely related. If we have values that are directly related or have direct variation, that means that when one gets larger, the other value must also get larger. Not necessarily by the same amount, but by what we would call a proportional amount. So a multiple or fraction of that amount. the expression for a direct relationship looks like this. Y equals a constant times x, where k is a constant that is specific to that relationship. So if we are told that y varies directly as x, what that is telling us is the relationship between y and x is that y equals a constant times x. Now, if we're told y varies directly as x and that y is 36 when x is 4, that's giving us some additional information. With that, we can actually solve to figure out what this constant is. So we know it's y equals kx. Y is 36, so I'm going to put 36 in for y when x is 4. So I'm going to put in 4 for x. We've solved equations before, so we know how to solve this. I'm just going to divide by 4 to get k by itself. So 9 equals k. So what that is telling us is, combined with our knowledge of what direct relationship is, I can replace k there with 9. So y equals 9x. So whatever x is, y is 9 times that. We might be told y varies directly with x, and y is 42 when x is 14. So let's find the relationship here. Well, we're told y varies directly with x. That's telling us y equals k times x. Y equals a constant times x. Y is 42 when x is 14 is giving us one condition in that equation, so we can find our constant. 42 goes in for y. We're looking for k. 14 goes in for x. So 42 equals k times 14. So we divide by 14 to solve for k. 42 divided by 14 is 3. So k equals 3. Any questions so far? Okay. So let's go one step further. Y varies directly as x, and y is 48 when x is 4. Find y when x is 7. So our first step here is still y varies directly as x. That's telling us y equals k times x is our form of this equation. Our next step, y is 48 when x is 4. So that's telling me I can put 48 in for y and 4 in for x and figure out what k is. I divide by 4 here to get 12 equals k. So that's telling me, combined with my generic form of the relationship, if I replace k with 12, the relationship's really y equals 12 times x, or 12x. And finally, it's asking me find y when x is 7. So now I replace x with 7, so 12x becomes 12 times 7, to get that y equals 84. let's say y varies directly with the square root of x. Y is 12, and x is 9. Find y when x is 25. So this one's just slightly different at the beginning. Instead of y varies directly with x, it's y varies directly with the square root of x. So instead of y equals k times x, it's y equals k times the square root of x. From there, everything else is pretty much the same, only there's some extra steps. Y is 12 when x is 9, so put 12 in for y, and 9 in for x. Got some intermediate steps to do here, though. Square root of 9 is 3, so 12 equals k times 3, and we divide by 3 to get k by itself. So 4 equals k. Now that we know that, we can combine that with our generic form of the equation. Instead of y equals k times the square root of x, we know that y equals 4 times the square root of x. And then asked, find y when x is 25. We put 25 in for x. Square root of 25 is 5. So 4 times the square root of 25 is just 4 times 5. Or 20. Y equals 20. Any questions there? Okay. Well, where would this come into use for you guys in the medical field? Well, let's say you know that the amount of medication administered is directly related. Notice I didn't say it varies directly with, I said directly related to. It means the same thing. I can say there's a direct relationship between the amount of medication administered and the weight of the patient as well. So there are a lot of different ways of wording that. Like I said, the amount of the amount of medication administered is directly related to the weight of the patient. I could say the amount of medication administered varies directly with the weight of the patient. I could say there's a direct relationship between these two things. When you hear the word direct, it means that y equals a constant times x. Here we're going to put medication equals a constant times weight. A 120 kilogram patient receives 600 milligrams of medication. So now that's telling us the medication is 600 when the weight is 120 kilograms. So now we can divide by 120. 600 divided by 120 is 5. That's telling us our constant is 5. So the relationship here is y, or not y, but m, the amount of medication, is equal to 5 times the weight, 5W. Now obviously it's not really 5 times, so it's not 100 kilograms times 5 would be 600 kilograms. So really what this 5 is is it's 5 milligrams per kilogram is what that is. There's units to it. So what this is saying is if you looked at the label for this medication, it would say 5 milligrams per kilogram per however, whatever period of time it would be specified. So then the next part is how much medication should be administered to an 80 kilogram patient. Well, we take this relationship and replace the weight with 80. So the medication is equal to 5 times 80. 5 times 80 is 400, and that'll be milligrams. So knowing that the medication varies directly with the weight of the patient, and knowing that this patient was at 120 kilograms received 600 milligrams, allows us to figure out that an 80 kilogram patient should receive 400 milligrams. Okay, the other side of the coin is an inverse relationship or inverse proportion. In an inverse relationship, inverse variation, if one number gets larger, the other one has to get smaller. And the other way around. If the first one gets smaller, the other one has to get larger. Our general formula for this type of relationship is y equals a constant divided by x. So if we're told y varies inversely as x, y is 6 when x is 8. What this is telling us, y varies inversely as x. This takes on the form y equals k divided by x. Y is 6 when x is 8. So we can put in 6 for y and 8 for x and solve for k. Well, it's k divided by 8, so to solve for k, we're going to multiply by 8. 6 times 8 is 48 equals, the 8's cancel, that's k. So 48 is equal to k. So instead of y equals k over x, y is equal to 48 over x. So if we're told y varies inversely with x, and y is 6 when x is 9. Find y when x is 18. So just like before, we'll start out with the relationship. Y varies inversely with x. So that's telling us y equals k divided by x. Second, y is 6 when x is 9. So I put 6 where the y is and 9 where the x is. And I solve. To get k by itself, I have to multiply by 9. 6 times 9 is 54. The 9's cancel out, so 54 equals k. So I put the k back into our relationship. Instead of y equals k over x, y equals 54 over x. And finally, find y when x is 18. It's telling me to replace 18 here, or replace x here with 18, and see what I get. 54 divided by 18 is 3. So y is 3 when x is 18. Any questions so far? Okay. When the first thing for any of these is just you got to start out with the relationship. If it says inversely, it's y equals k over x. If it says directly, it's y equals k times x. If they give you a set of values, like y is 6 when x is 9 in this case, that means you can replace the y and the x with those numbers and figure out what k is. So anytime you are given, it's what they call, the technical term for it is an initial condition. And all it is it's one point, it's one situation that makes that relationship true, or one situation that's described by that relationship. So when you're given that set of points, so a value for y and its corresponding value for x, whenever that happens, then you can figure out what k is and replace k with a number instead of having just k there. Because the relationship, k really is a number. So if we can figure out what k is and put it in, we should do that. So yeah, anytime you're given x and y, it's implied that you're going to figure out what k is and replace k in that relationship. So let's say we're told y varies inversely as the square of x. And let's say that we are told y is, what do I want to put in here? Let's go y is 72 when x is 3. Find y when x is 2. So again, we are told y varies inversely as the square of x this time. So instead of y equals k over x, it's going to be y equals k over x squared. That's the only difference. Then we are told y is 72 when x is 3. So again, we have a value for x and its corresponding value for y. So put in the values. X is 72 when y is 3. So 72 is equal to k over 3 squared. So now, we're not going to do anything with the 72 yet. 3 squared, however, is 9. So 72 equals k over 9. And now it's k divided by 9, so we're going to multiply by 9 to get k by itself. 72 times 9 is 648. So k is 648. So we'll replace k in our formula with 648. So instead of y equals k over x squared, y equals 648 over x squared. Now we're asked to find y when x is 2. So now that we know the relationship is y equals 648 over x squared, we can replace x with 2. So it's 648 over 2 squared, which is 648 over 2 squared is 4, which is 162. So when x is 2, y is 162. Now I'm going to pause for a second here before I go to the next example and just analyze this. One of the things that's very important to do when you're dealing with numbers is to step back and just do kind of a common sense viewpoint of things. This is inverse relationship. Y varies inversely. Oops, not the marker I wanted to have. Y varies inversely is the square of x. So what that means is if x gets larger, y has to get smaller. And if x gets smaller, y has to get larger. So we started out, x is 72 or y is 72 and x is 3. So over here we're going to try to find y when x is 2. Did x get larger or smaller? It went from 3 down to 2, right? So x got smaller, which tells us y needs to get larger. So we got y is 162. Did it get larger? It sure did. It went from 72 to 162. So that doesn't necessarily guarantee that that's the right answer, but it does make sense. It got bigger when x got smaller. One major application of inverse relationship is our ideal gas law. The ideal gas law says that the volume of a gas is inversely related with its pressure. I should just write this out in words. Sorry. The volume of a gas is inversely related to the pressure. Now there's a big condition here. It's assuming the temperature is the same. Because we all know as things heat up or cool down, they expand and contract. So as long as the temperature stays the same, the volume of a gas is inversely related to the pressure. Which, in other words, if you increase the pressure on it, it squeezes it down into a smaller volume, which kind of makes sense. Think of it like a piece of foam. If you squeeze it down, you increase the pressure on it, it gets into a smaller volume. You release it, you're releasing the pressure, it grows to a larger volume. Less pressure, more volume. So the relationship here is the volume is equal to a constant divided by the pressure. Just like y equals k over x, v equals k over p. So in this case, since we know this relationship exists, we might not be told that the volume of a gas is inversely related to the pressure. We might just be told a gas has volume of 120 cubic inches at a pressure of 40 pounds per cubic inch. Find the volume at a pressure of 17 pounds. Actually, this would be pounds per square inch, sorry. Pressure of 40 pounds per square inch was the original one. Find the volume at a pressure of 17 pounds per square inch. So again, we know the relationship between volume and pressure is V equals K over P. So we don't have to be told that there's an inverse relationship. We might be told, though, like I said, the volume is 120 when the pressure is 40. Now we can use that to find K. If I multiply by 40 here to get K by itself, 120 times 40 is 4,800 equals K. So that's telling us that formula is really the volume for this gas is 4,800 divided by the pressure. So that constant, K, I should make a note before we finish this, is different for each gas, each type of gas, nitrogen, oxygen, whatever. And it changes with the temperature. So that constant depends on a couple of different things. So now it says find the volume when the pressure is 17 pounds per square inch. So V equals 4,800 divided by 17. So 4,800 divided by 17 is going to give us an ugly decimal, 282.35. And that is a volume, so that is in cubic inches. Any questions? So I'm going to have you guys try a couple in your notes here. First one I'm going to have you try is a 90 kilogram patient receives 495 milligrams of medication. How much medication should a 70 kilogram patient receive? I'll give you a couple minutes to try to figure that one out. So let's take a peek. You know that the weight and the amount of medication is what type of relationship? Should be a direct, right? If the weight goes up, the amount of medication should go up. So the medication is directly related to the weight. So M equals K times W. So a 90 kilogram patient, 90 is the weight, so that goes in for W, receives 495 milligrams of medication. So now to find K, we're going to divide by 90 to get K by itself. 495 divided by 90 is 5.5 equals K. So that is telling us that the relationship is the amount of medication is 5.5 times their weight. So a 70 kilogram patient, we put 70 in for W, 5.5 times 70 is 385 milligrams. How many of you had 385? Well, good. Any questions on how we got that? So the big thing is when you see that it's medication related to weight, you have to remember that that is a direct relationship. So let's say that at 20 psi, a gas has volume of 30 cubic inches. Find the volume at 10 psi. I'll give you a few minutes to try that one. So we know this is an inverse relationship. The volume is equal to a constant divided by the pressure. So we put in 30 is our known volume when the pressure is 20 psi. So now we solve for K by multiplying by 20 to get that 600 equals our constant. We bring that up here. So the volume is equal to 600 divided by the pressure. When we put in 10 psi for the pressure, the volume equals 600 divided by 10. Well, 600 divided by 10 is 60. That is 60 cubic inches. What if I give you this example? The gas has volume of 20 cubic inches at a pressure of 15 psi. At what pressure would the volume be 5 cubic inches? Give you a couple minutes to take a look at that one. So this one kind of works a little backwards from what we did. It's still the same relationship. Volume is equal to the constant divided by pressure. We know that the volume is 20 when the pressure is 15. So we can find K by multiplying by 15. So 300 equals K. So far everything's worked the same. Our volume equals 300 divided by the pressure. But now we're asked find the pressure that gives us a volume of 5. So 5 has to go in for V equals 300 over P. To solve that for P, I mean, we're just solving an equation. But when we're solving an equation where the variable that we're solving for is on bottom, the easiest way to do that is to turn it into a proportion, like this. Make it a one fraction equals another fraction, or one ratio equals another ratio. Then we can solve that by cross-multiplying. 1 times 300 is 300, and dividing by the other one, divided by 5, which gives us P equals 60. So at a pressure of 60 psi, we would have a volume of 5 cubic inches. Any questions? Okay, it's time for a break, so let's go ahead and do that. We'll come back at 11:30.